Around 13.75 billion years ago, our universe, as far as we know it today, was created. At that time, the early stage light began to shoot through the universe and spread throughout the entire early universe. The actual universe, too, expanded. However, the expansion of the universe slowed down after the first emission of light. Since then, the rate of expansion has been steadily increasing due to the influence of dark energy. Essentially, the universe has been growing at an ever-increasing rate since its creation. Physicists and mathematicians have been studying the concept of the universe for many years, trying to answer the mysteries it contains. However, some scientists go even further into the unknown by pondering what lies beyond the limits of our universe. Is it possible that there is something beyond the existence of our own universe? Other universes whose existence we can speculate about? That could very well be the case. Here are 5 hypotheses about what this something could be and what pieces of evidence exist for the different speculations. If you like our videos, please support us with approval and subscribe to Basically Space to look forward to upcoming videos. Hubble volume, the concept of what lies outside the universe, is extremely interesting because first, the universe must be defined more precisely. A common term that does more justice to the point is the observable universe. Here, the speed of light plays a significant role because we can only see things when the light they emit or reflect reaches us. We can never see farther than the greatest distance that light can travel in the time the universe has existed. Cosmologists estimate that the oldest photons we can observe have traveled a distance of 45 to 47 billion light years since the Big Bang. This means that the observable universe is about 93 billion light years across, give or take a few light years. These roughly 93 billion light years contain all the quarks, quasars, stars, planets, nebulae, black holes, and anything else that we may have observed or might observe in the future. However, the observable universe only contains the light that has had time to reach us. This also means that the observable universe is continuously getting bigger. The universe is also limited. This limited part is also called the Hubble volume, named after the telescope that has given us the most distant views of the universe so far. We will never be able to see beyond this limit, so it is essentially the only universe with which we can ever interact. However, we know with a likelihood bordering on certainty that there is more universe beyond this limit. Astronomers believe that space, invisible to us, could also be infinite with matter, energy, universes, etc., distributed almost exactly as in the observable universe. Beyond the Hubble volume, we won't just find more planets, but potentially other planets exactly like Earth. In this far-off universe, you might find another planetary system with an Earth that's identical in every respect, where you had cereal for breakfast instead of eggs. Or another universe where you skip breakfast altogether. Perhaps a different universe where you woke up and then robbed a bank. Cosmologists believe that if you travel far enough beyond the limits of the universe, you will find another Hubble volume that is completely identical to our own. And in those other Hubble volumes, there will be another version of you, mirroring every possible decision you could make. This may seem far-fetched, but the infinity of the universe is hard to comprehend because it's just beyond human imagination. According to the theory of relativity, objects that are near one another can't move faster than the speed of light. However, there's no such restriction for objects that are very far apart. As the space between them expands, they can move away from one another at extraordinary speeds. Ultimately, this means that we could reach the edge of the observable universe if we developed a way to travel faster than the speed of light, a theory most physicists consider impossible. Or, alternatively, we could transcend space-time by using wormholes or warp propulsion, both of which most physicists also regard as impossible. Dark flow in 2008, astronomers discovered something very strange that they hadn't expected. Cosmic clusters were moving in the same direction at enormous speeds, over 2 million miles per hour. Groundbreaking observations in 2010 confirmed this anomaly, known as dark flow. Researchers found the phenomenon by studying the largest structures in the universe, massive galaxy clusters. These groups are collections of around 1,000 galaxies, an extremely hot gas that produce X-rays. By observing the interaction of X-rays with cosmic microwave radiation, CMB, left over from the Big Bang, scientists could study the motion of galaxy groups. The X-rays scatter photons into the CMB and shift the temperature in an effect known as the Sunyaev-Zel'dovich effect. This effect hadn't been observed before due to galaxy groups. However, it was first detected by an exploration team led by astrophysicist Alexander Kashlinsky at NASA's Goddard Space Flight Center. When the team examined around 700 groups, they compared these groups to the CMB map created by NASA's Wilkinson Microwave Anisotropy Probe, WMAP, satellite. The movement of these groups challenges expectations about the distribution of mass in the universe. After the Big Bang, one possible reason for this movement could be the influence of large structures outside the Hubble volume exerting gravitational pull. Scientists are almost certain that the source of the gravitational effect lies beyond our known universe. This would imply that the structure of the infinite universe is not uniform beyond our perspective, meaning that the structures could literally be anything, from collections of matter and energy on impossible scales to odd spatial points exerting gravitational forces from other universes. Endlessness bubbles discussing things outside the Hubble volume might be misleading because it is still the same universe, just parts of it that we cannot see. In another version of the story, the expansion of the universe after the Big Bang led to the formation of bubbles in the structure of space. Each bubble stopped expanding with the rest of space and formed its own universe, with its own laws and constants. In this scenario, space is infinite, and each bubble is also infinite, since a single infinity can contain an infinite number of infinite values. Even if you could somehow break through the boundary of one bubble, the space between bubbles would still expand, so you could never reach the next bubble, no matter how fast you move. Black holes, a hypothesis proposed by physicist Lee Smolin, known as the Fekin universes theory, suggests that each black hole in our universe causes the creation of another universe. Each universe will have somewhat different physical laws than the previous one. Thus, Smolin proposes a kind of natural selection for universes. Universes that lead to the creation of black holes are naturally selected to continue, while universes that don't form black holes eventually perish. The hypothesis has since been discredited by Smolin himself, as well as by others. Many parallel universes. There are countless theories about parallel universes. However, the most credible theory today involves a further development of string theory ideas. This includes so-called branes that oscillate back and forth. It would be beyond the scope of this video to describe string or brane theory in detail, but the core of the theory is that undulating branes in higher dimensions form entirely different universes. When the branes collide, a new universe is created. The effects of the wave movement help explain the observed distribution of matter in our universe. One of the strangest components of the theory is the idea that all the gravity we experience in our universe actually comes from another universe in another dimension. This would explain why gravity here appears so weak compared to the other fundamental forces. What do you think? Do other hidden universes exist outside our universe? Does infinity exist? If so, how infinite is it truly? Do parallel universes, the warping of matter, string theory, branes, and black holes hold any truth, or is it all just fiction? Leave us your thoughts in the comments.